Good morning. Yesterday I posted a momentum problem on Berry Science Lab website. Today, as I said, that I was going to solve this problem. So it's 4 a.m. here in New York City, and every day I'll solve a physics problem at 4 a.m. because that's the time when I wake up. Uh, so let's solve this problem. There is a grenade in the air. So if there is a grenade in the air, part 1 of the problem is grenade in the air. The grenade is 50 kilogram and grenade has some velocity. The grenade velocity is 100 meters per second. We have to find the momentum of this grenade. So to talk about momentum, let's remind you the definition of a momentum. Momentum is connected with impulse as well as collision. The symbol for momentum is P. The symbol for impulse is delta P. So momentum is Newton's first law, especially second part of Newton's first law. How badly a moving body likes to keep moving. Momentum is a vector quantity. So when we talk about body, a body has a mass. So of course, it's a product of mass and moving, which is velocity. So momentum is a product of mass times velocity. Impulse, when we talk about impulse, we actually talk about Newton's second law. So when we talk about momentum, we can think of the second part of Newton's first law. So we write Newton's first law. When we talk about impulse, we talk about Newton's second law. So let's write Newton's second law. Newton's second law, let's remind us Newton's second law, F equal ma. And A is the velocity over time, or to be more precise, the delta V over delta T. So F is equal to, you move the delta to the left over delta T. So we already wrote that momentum is mb, so we're going to replace this by p. So then delta p is equal to f delta t. So impulse is f delta t. There is a symbol for momentum, and that is j. J is f delta t. Okay, so we derive the equation for momentum using Newton's second law. Now let's talk about collision before we solve this problem. There are actually two types of collision: elastic and inelastic. Elastic, when conservation of momentum. Elasticity has to satisfy the conservation of momentum. Momentum before is equal to momentum after. Inelastic collision is also satisfy the conservation of momentum. P before is equal to P after. What about kinetic energy? Yeah, elastic collision satisfy conservation of kinetic energy, meaning kinetic energy before is equal to kinetic energy after, meaning there is no energy lost. Okay, Rama. In elastic collision do not conserve kinetic energy. Ke before not equal to Ke after. Elastic collision separate after the collision. In elastic collision stick together. The formula for collision is Newton's third law, of course. This Newton's third law. Newton's third law comes as a pair. So Newton's third law. So momentum is Newton's first law, impulse is Newton's second law, and collision is Newton's third law. So how Newton's third law look like? FAB is equal to negative FBA. So what does that mean? The force comes as a pair. Force comes as pair. So M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2 after. Obviously. Now let's go solve this problem. I'm sure we'll be able to solve this problem now. So as we said, there is a grenade in the air. We have to find the momentum of the grenade. So what is the momentum? P equal to M, which is 50, V, which is 100. So 5 kilogram meter per second. And is toward the east, because the convention is this is east, this is west, this is north, and this is south. Okay, we find the initial momentum. Initial momentum is 5,000 kilogram meter per second. Now this is 1A, 1B. Now few minutes later the grenade broke in three pieces in the air. The same grenade broke in three pieces in the air. The piece number one is, let's say, 20 kilogram, and it moves with 30 meter per second. And notice the direction. Direction is important because momentum is a vector quantity. Another piece is 15 kilogram, and it moves 20 meter per second to the east. The third piece is 15 kilogram. This is M3, this is M4. And we don't know the velocity of this. We have to find it. How can we find it? Let's see. Conservation of momentum will save us. How? We're gonna write Newton's third law. Newton's third law said F. Newton's third law, we're gonna write it like that. M, momentum before, is equal to momentum after. Okay. What is momentum before? MB. To be more specific, M1, V1. And then you're gonna write, so what does that mean? The force comes as a pair. M1, V1 is equal to M2, V2 plus M3, V3 plus M4, V4. We already found that, 5,000. We already found that, 5,000. M2 is 20. V2 is 30. Wait a second. The direction is important. This is toward the west, so we have to write negative. Plus M3 is 15 times 20. This time it is positive because it is moving to the east. Plus M4 is 15. And B4 is something we are trying to find. So 5,000 is equal to negative 600 plus 300 plus 15 V4. So 5,000 is equal to negative 300 plus 15 V4. If you move it here, that would be 5,300 is equal to 15 V4. So V4 is equal to 5,300 divided by 15. Oh, it says 353, I believe. Let's see, 5,300. Yeah, 353. That was, I was right. 353 meter per second. So this is moving. How fast? Very fast. 353 meter per second. Now, all of a sudden, it broke down. Instead of 3 pieces, 2 pieces, for example. I'm going to erase that. Okay. And instead of 3 pieces, let's say it broke into 2 pieces. It's broken into 2 pieces. And let's say the first piece is 25 kilogram. And it moves how fast? Let's say 10 meter per second to the north. And the another piece also 25 kilogram and it moves in this direction. We have to find the velocity of this, but notice that this has both component x and y. So how can we do that? But we know that this is Vx and this is Vy. That's how you're gonna find it. So what are you gonna write momentum before? Oh, let's do a different strategy. Let's write x and let's write y. This is for x component. This is for y component. So you're gonna write momentum before is equal to momentum after for x. This is momentum before is equal to momentum after for y. So let's see. Momentum before. So you're gonna write m1x. Oh, we're not gonna write x before because m is a scalar quantity. It doesn't have any direction. But b definitely has a direction. v1x is equal to m2 v2x plus m3 v3x. So m1 v1x, we already found that earlier. 5,000. m2, you notice that 25. v2x, there is no x component of the velocity, it's just y. So you're gonna write 0 plus m3, you notice that m3 is 25. And b3 is something we're trying to find. So this is 0. So 25 v3 x is equal to 5,000. v3x is equal to 5,000 divided by 25. 5,000 divided by 25, I believe, is 200. So this time I'm not going to check it by calculator because I'm kind of sure it's 200. 200 times 25 is 5,000. Okay. So x component is 200. Now let's find y component. m1 v1x. Wait a minute. It shouldn't be x. It should be y. Is equal to m2 v2y plus m3 v3y. Okay? So m1 v1y, how much momentum is at the y direction? 0. All the momentum is x direction. m2 is 25. v2 is 10. m3 is 25. And v3y is something we try to find. So 25 v3y is equal to negative 250 over 25. So v3y is equal to negative 10. Now we can use the Pythagorean theorem to find vy. How? We're gonna write 200 square plus we're gonna write negative 10 square, and that is 200.25 meter per second. 2, this is southeast. So the velocity of this is 200 meter per second to southeast. Thank you for watching. I'll solve a physics problem every day at 4 a.m. because that's the time I wake up, and I'll post this video on the website Body Science Lab. Thank you.